Okay, welcome everybody. This is great. This is the lunch talk here at JCON. And I hope you had something good to eat, or now is the time to get something, because this is going to be entertaining and also informative. We want to try to save the planet with Java and scale to 0. So let's look at our objectives for today. We will take a look at why you should care or your boss should care. Then we will see what the challenges are when we do scale to 0 for Java. And then we will talk about solutions and the problems of those solutions. As you can see, there's a nice flip here. A little bit about myself, so you can know why I'm talking in this way or about this topic, or why I have this opinion about this topic. My name is Richard. I've been in software for 20 years now, and I work at XDev Software. We do rapid clips, and I am also one of the co-organizers of JCON. And so from all of my heart, thank you that you joined JCON today, and make sure that you visit our sponsors that allow us to do JCON in the way we do. What we do at XDev is rapid clips. We had a few talks at the conference here because XDev is also a sponsor of the conference. And rapid clips is a cross-platform UI builder and a rapid application development environment. You can use rapid clips as you would use PowerPoint, but then it generates Java code, which is great. So if you haven't tried out rapid clips, go ahead, give it a try. It's free, it's open source, and it's real fun to build things with rapid clips. And if you have any needs with related to Java, just let us know. We also do, of course, consulting, because somehow we gotta finance all the rapid clip stuff we do. So yeah, give that a try too. So let's dive right into the talk. Why should I care about this topic, scale to 0? Why should my boss care? So this is always good to find that out before you go deeper into the topic. So this is like an extinction event. So like the dinosaurs, they died. The same for us. Okay, this maybe some people say that. I don't believe that we will all die, but some species on this planet will die when we do the things we do it today. And we got to change something. And scale to 0 would be one means to make the planet a little bit longer habitable for us and for other species. So it's a good thing. And this, of course, is Fridays for Future presentation. No joke. So, but it's about climate change, of course. So if you don't care about the climate and say, okay, until this hits, I'm dead, then maybe you have children or other relatives that are younger than you. For me, I have 2 kids. And this is maybe the reason why I do this talk, because I want to make a change in software development for my kids, so they have a nice planet they can rack up then. And it wasn't us that wrecked the planet, it was them. Okay, and if you don't care about like other species on the planet or children or other humans, then there is still money. Okay, so there's a lot of money in this, because scaling to 0, you will see this in a minute, means saving a lot of money. So if you don't care about the other things, just go for the money, okay? So what's your money doing in the data center? So most of your money is doing nothing. There was a study, it's also here in the show notes down at the slide, where you can read up on it, and it basically says 60% is doing nothing, because you have 30% zombies, which are just systems that you forgot to turn off. So this is always great, and don't tell me you don't have them. Everybody has them. And then you've got idle systems, and this is maybe something like a staging environment where you tested something, and the most of the time this is just doing nothing, but you gotta have it, right? So it would be great if that could go away also. And then you have 40% of servers that do real things, and they don't have always like 100% utilization, but they do stuff. So let's leave them alone for a minute and see what's the stuff doing later, okay? So, okay, there's a lot of money. We will have a look at this in a moment. But before we go to that, there is a different motivation to do something like this, and this is net zero. And you might think this is the same that I talked about before, because I talked about money and I talked about saving the planet, but there is, it's crazy. There is a different motivation behind this, because a lot of companies, they have the motivation of saving money. That's great, but they have also the motivation of providing a clean image, or they have a real issue with climate gases and they want to have a real change, and they have a goal, and they say, maybe bigger companies, let's say Microsoft, they don't care about cloud cost. They have their own cloud. Cloud cost is good for them because it makes them money. So they might not be interested in saving so much money in the cloud, but they might be interested in having services that don't pollute the planet. So this could be a good thing. And there is a Green Software Foundation, and they described a roadmap what you can do if you want to have such a climate pledge, and what are the things that you can do. And of course, they show in the slide that you have to reduce emissions, and there are two things you can do. The one thing is you can do offsets. So this is what you know when you book a flight, and they will ask you, hey, do you want to offset this? And they will plant trees somewhere for the reason that you took the flight, and you will pay for the trees, and then the planet is good. So that's not totally bad. It has some problems, but that's better than doing nothing. But the real good thing would be not to pollute the planet, so don't take the flight. So, and this is called elimination. So you don't do it. And scale to zero is basically this: you don't run the server at a certain time, so you don't pollute, so you don't have to compensate or offset for what you're doing. And this is not just like hippie talk. This is something that big companies believe in, even Shell. There are some people that we are allowed to cite on that, and I put them here on the slides, and they say, okay, this is really something that we should work on. So this is not just like for the planet hippie stuff. So this is real. And this is a slide that I saw, and that always made me think, taking a flight from Frankfurt here in Germany to San Francisco is roughly 2 tons of CO2. And this is just me sitting in my seat. This is not the plane. This is me sitting in my seat and flying. Person next to me, 2 tons also. So there's a lot of stuff, but also running a Dell PowerEdge, this is the one here in the comparison, with not the super highest specs. So 2 CPUs, 32 gigs of RAM. This is also almost the same for a year, okay? And if you take down one of those, this will allow you to go to Silicon Valley from Germany, okay? So there's also a lot of CO2 in this that we can save, and I guess you all have a lot of those running. And when I look at the things that we have running at our company, there's a lot of stuff running, so we should take care of this. Let's have a look at some scenarios how we can address that, or how we can start. So, and if you have questions, just write them in the chat. I will monitor the chat, and then I will answer them. Okay, Sasha, very good. Sasha says, but only one-way flight, or is it so you must stop 2 of the servers to come back? Yes, you must stop another server to come back. You must stop 1 to get there and 1 to come back. Right, good question, yeah. Okay, so this is where we start, okay? How we do things in the cloud, and what we can do. And this is the startup journey. So yeah, super cloud native app. You can do anything because it's easier. You ask, what's the problem? The problem is not that. That is easy. The problem is this one. Okay. You want to go to the cloud, do something in the cloud, and you have legacy software. This is a monster, and it will try to kill you every day. And as you see, we have a lot of casualties already. And we have brave sysadmins that had swords, and cloud architects that are wizards and all that stuff. So a lot of fun going on here. So what I will talk about in this talk is not using like the latest tech to write a new app. This is easy. I will talk about apps that are in production today and that have a life cycle left of, let's say, 5, 10, 20 years. they will be in production, and I think we should take a close look at them, because the cloud native stuff, that is easy to scale to zero. You write something that runs in a cloud function, AWS Lambda or something like this, and this is easy. But it's not easy for something that runs today and that was not made for the cloud and was not made to scale to zero. When we look at like regular business software, and we're talking Mittelstand in Germany, so smaller to medium-sized companies, they don't have like worldwide usage. They don't have like 17 time zones. This is just regular business software that is running everywhere. So I get it. Netflix must be on all day because you need to stream your stuff. Okay, this is a whole different CO2 and climate destroying story. But let's look at this one. So in this simple software, in this simple business software, you have 24 hours on the x-axis, and in the y-axis you have the days of the week. Okay, and you run all the time. So every dot means you are up. So this is 100% running your machine 24/7. And I think this is what most software systems do. And the whole truth would be, there is not just one node, there is 2 or 3 or 4, or depending on what your availability requirements are. So this is running all the time. This is bad. So the simplest solution would be saying, okay, here in Germany, people usually work somewhere in this time frame, so 12 hours, and we will run the software just 12 hours, do a cron job, shut it down, bring it back up. Okay, and this will save us 50% of all the costs when you run it. So this is great. Then you can optimize further. Usually, most businesses don't operate on the weekends. So now we're cutting Saturday and Sunday, and then we are at 64%. Yeah, so this is just simple stuff. But when you propose this, first thing that people say is, oh no, I have to work on this day, and I have this one colleague, she's coming in early, and he is working late, and stuff like this. So in reality, it would look more like this. So our simple approach that we can just use a cron job to shut down the application and boot it up anytime in a fixed time frame, this would not work. Or I would say it would not be accepted by most users. We gotta put into account that usually software takes a little time to come up when you don't have like a cloud native application. So it could take some time to bring it up. And so it would be good if we could know when it comes up. So yeah, it would be great if we could start it before the first user would use it, because the first user will have to wait. If we do something like this, where we do it on demand, so we would have some different script, and the script would allow us to start the software when we need it and shut it down when we don't need it. So this would be the ideal solution, right? So, and this is what we're trying to do, because then everybody has what they need. When they need to use the software, they can use it. And if nobody is using the software because there is a birthday in the office, and on this Wednesday nobody is working, the software would just shut down and save CO2 and save money in the cloud, save the planet and all that stuff. Okay. So that's serverless, right? So I've got this nice definition from the cloud software foundation, and they say, so this is an application that do not require server management. That's great. We will talk about this in a minute. This is really nice. And they talk about this deployment model where you can just put your application there and it will magically be run. And of course, we know serverless means there are servers, but you don't see them. So this is all good. And then they say it's executed, scaled, and built in response to demand. So that's really great. And we will see that this is not the same as serverless. But first, let's talk about good things that happen here. One good thing that is happening here is when you look at traditional cloud approaches, then you get this shared responsibility model, and then the cloud provider basically says you can use this infrastructure from me, and I will take care of the data center, and will make sure that nobody can run into the data center and carry out all of the servers and stuff like that. And then you have to take care of different things, and there's the blue ones, and there is things involved that I don't like so much. So operating systems, patching, network configuration, stuff like this is not so good. So when you look at, in contrast, when you look at serverless things, in this case from AWS Lambda, then you can see that AWS will manage everything, and you can focus on the things that you like in your application. But again, it does not say anything about scaling to zero, because there's another definition that scaling to zero means having 0 replicas when idle. Because the other definitions, when we will look at some of the cloud services, not just AWS, we look at a whole range of cloud services in a few minutes, you will see that they will not scale to 0. They will scale to 1 replica, or they will scale to a half replica or something, but most of them, they will not scale to 0. And this means that there's still something running, and that's not what we want, because you might say, it's great, you scale down one big application that had 20 nodes to 1 node. That is great. But my problem is I don't have just one application. I have hundreds of them, and then I still have 100 things running that don't need to run. And then when you scale this up, not just for me, but for let's say all the people in this talk, we have a lot of stuff running that does not need to run. So I'm saying serverless is not always equal to scale to 0. So this is not all the time the same. There are good services that have the same, that can do it, and we will have a look at them in a minute. But let's come back to this slide. So we're gonna have some fun with zombies. Let's talk about the zombies first. So scary, scary, scary zombies. So the best solution to dealing with zombie servers is bring out the shotgun, run into the data center and shoot some servers with the shotgun. That's always fun. And this saves a lot of CO2. Makes a lot of damage, costs a lot of money. You will lose your job, but hey, you gotta make some sacrifices for saving the planet. In all seriousness though, please don't shoot any servers, don't use guns. What you can do is you can just turn them off. And there's one method from Microsoft, it's called the Scream test. So they will do something like displaying a message and saying, hey, this is a server, we don't know if you use it because looks like you don't. And then a little after that, they will start restarting the thing, and then they will shutting it down, and then they will retire it. And it's called the Scream test because they know if there is somebody using the server when people start to scream. So fun thing, and I would recommend that doing that for normal servers. But again, if you had scale to 0, then those zombie servers, they would automatically shut down because they would know that nobody is using them, and they would go away automatically. So they would be taken care of without doing anything. So great. Or you just manually turn them down. So, okay, the zombies are gone. We've lost the blue 30% of our problem because they are off. Either you shut them with the shotgun or you turn them off, your choice, but they are gone now. So for the rest, we can't just turn them off because turning off production is usually not such a good idea, and turning off idle systems is gonna wake you up at night because then this is the moment where people need them. So let's talk about scale to 0, like what this talk is about. And again, with the Java, we have some special features that we need to take care of because Java applications usually, at least in the past, were not made to scale to 0. We have application servers, we have some slow startups. The JVM, we will talk about this in a minute, has startup problems. We have Java EE applications, not only Java EE, but we have caches, we have other crazy architecture people come to me and say, hey, I really want to do scale to 0, but we at the first thing that we do in our application, we load everything from the database into memory. Okay, this is a valid idea, but if the database is really, really big, that could be not such a good idea for a scale to 0 approach, because this makes the startup go slow. And then we have a big memory footprint, because we were used to run on big machines that were always on. So yeah, maybe you will take a look at this. And I think I saw Dirk here. Dirk Weil has a good talk for converting Java applications to Quarkus or cloud native or cloud ready applications. So if you have Java applications, maybe this could be a solution for you if you can rewrite some code. So, and then you get state. So this is the most horrible thing ever. And we got a lot of state. So when we compare this to the 12-factor app, which is a guideline for cloud native readiness, I'd say you could see that there are 12 things you should consider. And I would say that most of them are not a problem for regular legacy applications that run today. They can do most of this. They have problems with this 6th point where they say you should execute in processes and be more stateless. Yeah, that's bad. And then of course, disposability. So you can just throw it away and start it up again. This is not what usual software systems do. And I would say this is I think most of them could handle this if you give them a little bit of time to shut down gracefully. But this is what people are most afraid of. If I go somewhere and tell them, hey, just shut this down, and they will say, okay, what is when it not comes, it comes up again, and we have a problem. Yeah, that's a problem. But you have the problem anyway because the servers will go out from time to time. So yeah, I would say it's more like a unit test. So you do it regularly, and then you see that you can build confidence that it's working when you shut it down and you bring it up again. So okay, let's see what we can do about these problems. One of the problems, of course, is state, and then for state we would have to cheat a little bit because yeah, when your application is going down and you need to save the state, you could use something like a cache, a persistent cache, to store this, because then again the cache has to run. Then you can use a database, and then again the database has to run. There are some serverless databases. Amazon has a good one, DynamoDB, but you have to take care in the version 2 of DynamoDB. It's not so serverless. I guess it's serverless still, but it's not scaled to 0 anymore. So they have to keep something running. In the first version, they could shut it down completely, which was great. And then, of course, you can do tricks with cookies, sticky sessions, tokens, and I don't want to go in all to the Kubernetes stuff. Then you can do a lot of things there to have state in those systems. But this is always the hard thing to do this. And one thing you could do is you could use MicroStream in Java to store data. I really like MicroStream because it helps here with scale to 0, because you don't have to implement interface or any annotations, and it's very fast and secure. So very fast is important because we need a fast startup. So this is good. And the point with not to have to implement an interface or annotation means you can use an existing code base and build an adapter with MicroStream. And this is usually a good point because people don't want you to touch classes or systems that haven't been touched in many months or years, and they rely on that they run. And then you say, okay, I want to implement interfaces on those classes. They won't take this very lightly. So this could be a good approach to do that. So the state topic is clearly one of the hardest, and it depends from application to application. So you have to look into that. Easier challenge is the startup challenge for Java. And as you can see, this person is very motivated to get it running. And we have a nice graphic here from Holly, from the Quarkus team, that says how fast it can be. And as you can see on the, you have a LED light which goes on very fast, and then we have like literal fluorescent lights. This takes long, but as you can see, having a normal app takes a few seconds, and if you use Quarkus on a regular JVM, it is fast. So again, Quarkus is a cloud native approach, and if you do Quarkus native, which uses GraalVM native images, then it's very, very fast. Okay, so we can do something here to make our application start fast. And this again is important, because when you start your application on demand and you have no nodes running, then the first user that will use the application after it has shut down or went to sleep, let's say shut down, because sleeping means it's alive, we want to kill it, it must be dead. So then it's important that it comes up really, really fast. And with Quarkus, you can do this, but this does not help us in our case, because we have to deal with legacy applications. So let's see what we can do. But we can leverage like the same techniques. There are some things going on in the JDK. There is Project Laden, which deals with accelerating the startup of a system, and you can do this with an existing system. And of course, there is Oracle GraalVM and their native images. And the deal here is they say, we will take a look at the application when you compile it, and we will throw away the Java virtual machine and compile it so that it fits to the architecture and the processor that you will run it on. So this sounds a lot like C, and it's a lot like C. But this is great, because then your application is really small. You don't have a Java virtual VM. You don't have bytecode files that get interpreted by a JIT and all that. But again, you have to do it for the targeted platform. So if you want to run this on a Linux, on a certain a processor architecture, then you have to compile it for that. If you want to run it on a different processor or operating system, you have to compile it again. And the compile, of course, takes a long, long time, which is usually okay, because you compile your application, then you deploy it, and then a lot of people use it. So this is an okay trade-off. And from that, you get a very fast startup, because there is no JVM that needs to be started. There are no classes that needs to be loaded. This is all analyzed before and looked at, and then you can start, and it's good. And you have a very small memory footprint, because there is no JVM running. It's just running what you use in your application. So this is very, very good. Okay, but this has some downsides. One of the downsides is you don't have a Java virtual machine anymore, which means you don't get to get things free, like a flight recorder or monitoring that you can just plug into when you have a Java virtual machine running. This is going away. So you don't have that anymore. This could be a downside of this. And when we talk about JVM startup, this is a nice slide from Garrett, which defines it very good. Is JVM startup is not starting the JVM, usually talking about warm up, because what will happen when you start the JVM, it will start up. This is fast, I'd say, but then there is warm up, where the JVM will look at stuff that you do, count how many, which method is called how often, and then the JIT compiler go to work and will warm up the JVM and will take care and make it really performant. And as you can see here, after the startup phase, we got good, nice performance, great speed. And this startup phase is not so good if you scale to 0, because it takes some time, and you should like really work your application. So if you start it up and you don't call anything, then nothing is happening. And if the first user calls the first use case or REST endpoint or method, then this method gets called, and then the JVM starts to optimize that. So in comparison, if you look at this one, this is what you do with ahead of time. That's that AOT, ahead of time compilation there. This is what GraalVM does, the black part. And then they have a guided optimization where you run the application and GraalVM looks at it and tries to figure out what is happening and tries to optimize even more. And with that, you get a really good startup performance, but it's all done before, so it cannot optimize in the process. And sometimes users do things differently than you would expect. I guess that's happening all the time. And the JIT compiler can optimize for that, and that's good. And that's what you're not getting here. So you get the optimization level that you build at build time, and with a running JVM, you get optimization level that is done at runtime. There are other solutions. This one is called CRIU. That's a Linux solution from the Linux kernel. I would love to have this called CRIU, but again, I think there are products that are already called that. So CRIU, and this is something that OpenJ9 uses. And I talked to Emily, and she said they had a really great performance improvement, and they can start up OpenLiberty with this optimizations in under 100 milliseconds, which is really great. And also there's a commercial product from Azul. It's called Prime, I think. Prime is the product that you can buy, and there's a feature that is called Ready Now. And Ready Now is basically skipping the warm-up phase. So you still keep your Java virtual machine, which is good, so the JIT compiler can work, but you store the optimizations. So as you can see in the orange line, when you start up, that's what we saw before, you have a time where the JVM needs to optimize, and then when it's warm, you're getting nice latencies. And this warmed up state can be saved. And if you save it and give it to the JVM as you started, you have basically a warmed up JVM, which is great for when you want to scale to 0 and bring it back and have a JVM that is very performant right from the moment that you started. So this commercial feature from Azul, you have to check this out. Okay. So, I said we want to kill people, applications, sorry, and zombies. But killing is the one thing. Declaring death, this is when you need a doctor, because you need someone to figure out when this thing is dead and is disposable, and you can shut it down. And we will look at some containerful serverless services from different vendors, and there are a few, and they all have problems, and I wanted to share the problems that I found, and maybe they're not true, or they've gone away in the meantime, but I found some that worked good for me and one that would not work so well for me. So let's start with the obvious one, AWS Lambda. This is the go-to place for serverless stuff, and I've included this in this comparison because it has now the ability to run containers. So basically, I could run a legacy application if I package this in a container. So I would not have to rewrite the whole application. I could build some adapter classes that would funnel the AWS Lambda calls into my application and outward. But usually, this is not the way to go. Yeah, that's just not the way to go. Then, of course, there is Fargate, which, in my opinion, works a little bit better. So this is basically something like Lambda. You give it a container, and this is serverless. You run it, and you could do some tricks with CloudWatch to make it to scale to 0, because this will not scale to 0. It will keep one instance running, but you could scale. You can scale it down. Excuse me, you can scale it down. You can say I have a desired count of instances of 0, and it will scale down, and you can bring it back up, but you have to fiddle a little bit and trick the load balancer, because it will give you an error, and then you have to catch this error and then have to start it up. So this is a long time until it starts up. So there's no native way, at least that I found, to start this up again. And then there is AWS App Runner, which is a little bit better. They can do a scale to 0.05, so they will do some magic that it will not use as much resources, but to avoid the cold start, but then again, it's still running. Then we have something for the Java world, Payara Cloud, which is super great serverless product where you can just take a var, give it to Payara Cloud will run it. You don't have to take care of a lot of the tedious stuff, but unfortunately they cannot scale to 0. But I talked to them and they said this is an interesting idea. Maybe they will have it in the future. Then again, there's Oracle. Nobody talks about Oracle Cloud, right? But they have a feature coming up, and they have some marketing slides about that. Nothing that I could try out until now, but this is just what I wanted. This is container instances start up in less than 30 seconds for a 200 MB container, which is okay, I would say. And workload stops, your container instance is stopped, and your billing stops. So I believe that Oracle will do that, because when it's about money, I think they are very straightforward with you, because this is where they know their stuff with money. So this could be a great thing, but that's not out yet or is not running yet. Then there is Heroku. Sad news, they canceled the free tier, I guess, but the free tier was the best, because in the free tier you could have applications that would sleep after 30 minutes of inactivity. So this was the best feature. I talked to someone from Heroku. They said this feature is not available in the other tiers. This is sad, because I would like to pay for that feature. So I would take a checkbox, because they seem to have it already in their infrastructure that they can do it, and then you could scale to 0. Would also be fun. Then, of course, there's Knative. So Knative is a way to give a container to Kubernetes and treat it as a serverless container, and then Kubernetes will run it on the cluster. So this is really cool. I like this approach very much, and it's not so vendor specific. So this is great. And also there's Roland Hus, which works intensively on this and has a great talk about this. So you should give that a try. And then, but Knative I have to run myself, which is not the preferred way for me to do it. I want to get a service where I can just buy this. And then, of course, there is Google Cloud Run, which is basically Knative, and you get 2 flavors. One flavor at Google Cloud Run is you get Knative on App Engine, which has a little bit different semantics than Knative on Kubernetes, because Knative is, when it's not running on Kubernetes, it behaves a little bit different, but it's all in the docs. I have a link again here for you where you can read up on all of this. So this is a great service, but the scale to 0, I was not convinced, and then I found IBM Cloud Code Engine, and this just works the way I want it to. And this is something I want to show you. I have a browser window here. So this is the backend, and of course I have a pizza demo because I'm always hungry and I like food, of course, pizza. And it says no instances running here. Okay, this is good. This is the state I want. I want not to run this. I want to start something. And then again, I have to see, where do I get my, I will show the endpoint and you will call it all the time, and now it will run all the time. Okay, let's take this one. So, and then now I run it. So, and it will take a few seconds, because when I tested this before, IBM Cloud Run takes, I'd say, somewhere from 20 to 30 seconds to spin up the infrastructure. But they won't give me like an error, but my request is still waiting and waiting for timeout. And I hope the timeout is longer than this. And my application will take 10 seconds to boot up or something like this. And then I get a call. It's not perfect, I know. And this call should start up here, my instance. And as you can see, now one instance is started. This is good. 1 CPU, 4 gigabytes of RAM, and it started. It's running now, and I should get back a response. And important for me, no error, because I want to have a transparent startup. I know this is too slow still, but if we can get that down to, I'd say, 10-15 seconds, this should work. And then the thing is up, and then it will, of course, it will respond very fast because it runs. Okay, the demo gods are not on my side today. So usually this is faster. Okay, but we see it's coming up. Okay, we give it a few seconds, and in the meantime, we look at this wonderful UI, and it's just that simple. You can say I have a min number of instances and a max number of instances. The only thing I don't like about this IBM approach is they don't give me the metrics or configuration that allows me to configure what is the point of death for my application. Because in legacy application systems, oftentimes you can't rely on just requests coming in and say, okay, if there's no request for 10 minutes, you can shut down. Sometimes you have long-running processes, and for example, with microprofile metrics, you could easily have metrics that tell cloud systems, hey, I'm still working on a long-running batch job, please don't shut me down. And then you would have the metrics say when everything is finished, hey, I'm not doing anything and I even haven't got requests in the last 13 minutes, then hey, you can shut me down. And this would be the perfect solution for me. So let's see if we are there now. So, it worked. Yeah, a nice hello world wanted application. We are here now. As you can see, we're running, and yeah, it's running. So, okay, I didn't put the code. Yeah, and here you can see I did this a few days before. It will shut down after 20 minutes here. It will shut down, and I won't pay. I won't use any resources. That's great. And I would encourage other vendors to implement something like this. So make it easy for me to scale to zero. Making my own application able to scale to zero is hard enough. So it would be nice if I could just have a cloud service that helps me with the deployment. Okay. So conclusion for this talk is, Scale to zero, in my eyes, could be a game changer in terms of cloud cost and resource consumption and CO2 emissions, and could allow us to fly to the Caribbean 2 times a day if we could just shut down more servers. No, just a joke. Don't fly to the Caribbean every day. And then you have some challenges, of course. I told you that it's not easy, but you know your software products or systems better than me. You can face them. And yeah, we should find out what the use cases are out there, and should discuss this. And I'm open. I have my Twitter on and all that. If you want to discuss this or have ideas, this is something that really moves me, and so I'm really interested in talking about this. And yeah, we still have some time to do this. Before we go to Q&A, I like to point out 2 talks. Martin Lippert and Roland Huss, they have 2 very good talks. You can find them on YouTube also. One about sustainability in software engineering, if you are more interested in the part of sustainability, not so much on scale to zero. Martin had a nice talk at JCON last year here, and that inspired me. And also Roland Huss has a talk on Containerful Serverless, where you can get an in-depth view of the options you have for running container serverless in the cloud, which does not focus at all at sustainability, but only on the technical side with containers. So you get the best of both worlds here. And with that, you have my contact info here, and we still have some time for questions if you want to talk or discuss about scale to zero.